There are a couple main ideas here that I want to make sure we understand. One of them is that we use rectangles to find out area under a curve. So if I use this one big block, that kind of estimates, well, it doesn't really do a good job of estimating the area under this curve, but it is an estimate. But as I increase the number of rectangles or decrease the dx, the delta x, as I decrease that, we can see that our estimations using the rectangles start to get very, very good. They look nicer and nicer approximations, and those rectangles seems to match the area under the curve better and better and better. The other part of it is that this area under the curve has something to do with an antiderivative. So x plus cos x, the antiderivative is sine x plus 1/2 x squared. And if we take a look at the displacement or the difference in the antiderivative function at x equals 5, that's my endpoint here, and x equals 1, which is my endpoint here, this displacement here, f of 5 minus f of 1, or big F of 5 minus big F of 1, gives me this displacement. And that seems to indicate the same area under this curve. So as I do this, we can see that it's converging to that value of about 10.2. So two things. If we want to get better accuracy, we let the delta x go to 0, and we can use a limit to make this exact. It seems that that limit then has something to do with the antiderivative, and it has something to do with being able to find this area by calculating the difference in the coordinates of the antiderivative.